All right, Unit 6. Lesson 1, we're going to be talking about perpendicular and angle bisectors, which is nothing new in a way. We've talked about bisectors before, all right? But now we're going to add some flavor to it. So a perpendicular bisector, what that's doing is, so we have AB here. This is a segment, AB. Well, this line, if you notice, is cutting it in half, 2 equal pieces. Okay? So that is a bisector, right? But we could have a bisector, come through, like, so let's say this is the middle. A bisector can come through at an angle, any angle, and still, mark these two in half. But we're now adding the caveat of a perpendicular bisector. So not only is it cutting AB in half, it's also perpendicular to AB. So here's an interesting theory. If a point lies on the bisector, okay, then it is equidistant, that means equal distance from either endpoint. So what that looks like if we had it fresh is, here's our line or segment. And if I come through with a bisector like so, and it's perpendicular, then if I put a point here, this line is going to be the same measurement as this line. If I put a point here, this line will be the same measure as this one. If I put a point down here, this will be the same measurement as this. Kind of cool. And then the converse of that is if a point is equidistant from the endpoints, then it lies on the perpendicular bisector. So if we know that this point has the same distance to A as the same distance to B, then it is on this perpendicular bisector. Okay? And it has to be both perpendicular and a bisector. Because look, just imagine if my perpendicular line was over here, well, that's clearly, not going to be the same distance. Okay? So it has to be a perpendicular bisector. All right, find each measure. Find RS. Well, first off, we have a bisector. SQ is a bisector. That's important to know. And it's perpendicular. So if we have this point out here, S, this line here is going to be the same measure as this one, so 6.8. The converse, we have a point here. Here's a bisector. Since this and this are both 24, that means those two are equal, so this is 9.5. But be careful, notice it's asking for EG, not EF. So we actually have to take 9.5 times 2 and get 19. Always pay attention to see what it's asking for, not what you assume it to be. All right, now a little algebra. We again see that these two segments are equal, so this is a bisector, which happens to be perpendicular. That means this is equal to this. So we just write this is equal to this and solve. We subtract 3x from both sides. That gives us 2x equals 14. And if we divide by 2, x is 7. But we're not trying to solve for x. We need AD. Well, AD is right here. So 5 times 7, I know how to draw 7. AD is 35 in length. All right, is there enough information in the diagram to conclude that the point N, down here, lies on the perpendicular bisector of KM? Well, we know it's a bisector, all right? And even though right here it looks like it's a right angle, we're not given the mark. We don't have this marked on there. So without that mark, no. We do not know. That is the word no, but let's try it again. That KM is perpendicular to LN. Okay? It looks like it is, and most likely is, but we don't have it proven, so without that, we cannot make the assumption. All right, now, angle bisector theorem. So if a point lies on the bisector of an angle, so we have this big angle here, BAC, I'm over-exaggerating. AD is bisecting it. We can see that because of these two marks. Okay, so that is an angle bisector. Well, this point out here is equidistant to the two sides, and it must go at a right angle. So those two are equal. And the converse of that is, of course, if we know that this point is equidistant from these two rays, then we know that AD is an angle bisector, and we know this happens. All right, find the measure of GFJ. GFJ is this right here. So this is the converse one. Since we know this is 7 and this is 7, we know this line right here is an angle bisector, which means this and this are equal. So therefore, 42 degrees. Now the original one, since we see that this and this are equal, that means this is an angle bisector. All right? Since this line is 90 degrees and this one's 90 degrees to the rays, we know that this is equal to that. So we just set it up that way. 5x equals 6x minus 5. If we subtract 6x, we get, careful, negative x, or negative 1x equals negative 5. We need to divide by negative 1 and get x equals 5. But again, we're trying to find out what RS is, so we need to plug 5 in right here. So 6 times 5 minus 5 is 30 minus 5, which is 25. We could have also just plugged it in here, which would have been quicker because they're the same. 5 times 5 is 25. All right. A soccer goalie's position relative to the ball and goalposts forms congruent angles as shown. So this and this are equal. Will the goalie have to move farther to block a shot towards the right goalpost or the left goalpost? Well, since we know this is a bisector and he's on the bisector, he's standing there on the bisector, that means this distance and this distance are the same. I don't know why I made it look like a 4, but you know what I'm getting at, okay? In other words, he is in the middle. So neither one, distance is the same. All right, last one. Write an equation of the perpendicular bisector of the segment with endpoints -2, 3, and 4, 1. So this is one of those problems where for some reason they put the graphic in that actually already has the answer. So originally, all you should have had is, this information, PQ. Okay? You graph that. We need to find that. Okay? So if it's a perpendicular bisector, it needs to go through the midpoint. So how do we find the midpoint? Remember, midpoint, we add x plus x and divide by 2, and y plus y and divide by 2. So for this, we take -2 plus 4 and divide by 2, and 3 plus 1 and divide by 2. So that's going to be 2 divided by 2, which is 1, and 4 divided by 2, which is 2. So there's where we get the midpoint of 1, 2. All right. We have that right here. Now, it has to go through at a perpendicular angle. Okay, the slope has to be perpendicular. So we need to find the slope of our original line. Well, if we didn't have a graph, we would have to do m equals y minus y over x minus x, which would be 2 over negative 6, which is negative 1/3. So that's the slope of this line. Or we could have just gone and counted 1, 2, 1, 2, 3, 4, 5, 6, and gotten negative 2 over 6 just by counting on the graph. So either way, using the formula or just counting if we have it on a graph. So if this is the slope of the line and we want the perpendicular slope is opposite and reciprocal. Positive 3 over 1 or simply 3. So now that we have all the information we need, we have the slope and a point. We write y equals mx plus b. We put in our y, we put in our m, and we put in our x and find out what b is. So that's 2 equals 3 plus b equals negative 1, and there we have y equals 3x minus 1, which we already knew because they gave us the answer, but that is mathematically how you find it.